Alright, so in this equilibrium video, we'll look at calculating equilibrium concentrations. So given K, knowing what the equilibrium concentration is, now the question becomes, can we find a concentration? So in the past, we've used concentrations to help find K. Now we're going to do the opposite. So we'll look at sample exercise 15.10. It says for the Haber process, N2 plus 3H2 goes to 2 NH3. And all pieces are gaseous here, so I won't write the little g down below each one. It tells us the K is equal to 1.45 times 10 to the negative fifth. They put a little p down here to let us know that it's K in terms of pressures, atmospheric pressure, or the atmosphere is a pressure that it is. In an equilibrium mixture of the three gases at 500 Celsius, the partial pressure of H2 is, notice they said it's an equilibrium mixture. Do you see that word? Sometimes you just skip over that. So that means if you're making an ICE table, where would you put it if it told you it's an equilibrium mixture? Well, of course, you'd put it here at equilibrium. And so they're already telling us what that is. Okay, it says the partial pressure of hydrogen is 0.928, and that of nitrogen is 0.432. Both of these are in atmospheres. I'm just going to ignore that right now. What is the partial pressure of NH3? So this is the thing we don't know at equilibrium, so I'll call that X. Now, it doesn't tell us anything about the initials or the changes, but that's okay because I'm only interested in finding the equilibrium concentration or the equilibrium pressure as it is right here. And I'm given K. And remember that K is always equal to products in H3 raised to the second power divided by reactants, N2 raised to the first power times H2 raised to the third power. And I would take the equilibrium pieces and put those in here and here. And then since I don't know this one would be X, in this case, X squared. So N2 is 0.432. H2 is 0.928. Don't forget to cube that. And then NH3 is X. Don't forget to square that. And then this is equal to 1.45 times 10 to the negative fifth. Now we have to solve for X squared, so we bring these things to the other side and multiply them, and then we'd square root both sides, and then you can try the algebra on your calculator if you want, but X, which ends up equaling NH3, ends up equaling 2.24 times 10 to the negative third. And that would be atmospheres because both of these are in atmospheres. Now if you want to check it, you could go ahead and put this back in here and use these same values right here. Don't forget to cube this one for here and see if that ends up being K right here. Should work. That is one example of calculating equilibrium concentrations when you're given the equilibrium concentration.